The VEX Robotics World Championship is our largest event. This year, we welcome over 2,900 teams. That's over 30,000 students from 40 countries to VEX Worlds here in Dallas, Texas. They're all here to celebrate their success, meet new friends, and have a good time.
Teams from all around the globe have been competing all year to qualify and compete here at the World Championship. There are thousands of teams here, but only a handful of them are walking home with that trophy. But the rest of them, they're not going home empty-handed or empty-hearted. They're learning a ton of new lessons with regards to teamwork, working with people from other countries, other states, other regions, stress management, project management, in an environment that isn't really like anything else that students can get, especially at this age.
Doing what these students are doing here is hard. It's challenging. It's emotional. The competition is an important part of the motivation and the reward for that. They see the fruits of their work.
Getting to the state championship, getting to the regional championship, knowing that you are the strongest competitor in that area is the highlight. But we want to celebrate the success with people from all over the world because we believe robotics is more than just the competition. It's actually the language of robots and talking robots with people from different cultures. So we create this incredible event that brings people from all over the world so you can learn about different cultures, learn about different programs, and oh yeah, at the end of it all, we do crown world champions and you will see some amazing robots.
They are coming together. They have worked for months and months on their robots, and so we are here to help celebrate that. Yes, we are competing, but really it's about learning from each other and coming together to celebrate robotics and all that it provides.
VEX World, so it's like a new experience, meeting new people, making new friends, more memories that will last like a lifetime.
From my pit, I went around and I met so many people from different parts of the country and the world. It was very nice seeing those people. It just felt like a very welcoming atmosphere.
What's so cool about VEX World is that you have all of these students from all over the world getting to know each other, getting to collaborate with one another, and in the future they're going to be collaborating on projects to send missions to Mars, to build the next solar array, to do great things for our world.
I chose VEX Robotics because the Air Force uses a lot of robotic entities to get the job done as far as explosive ordnance disposal is concerned. All the robots and all the different nationalities you see here that work so hard to come and be qualified to come to an event like this. Those type of skills and those type of skill sets are crucial to learning.
Where else in traditional sports do kids come together to compete internationally? Well, they're able to see and experience just a different level of engineering. Every year I tell people when I go to Worlds, no matter how good I think our program is, I'm humbled within 5 minutes as to what's out there and what these kids can do.
To our administrators and teachers, VEX Worlds is a big deal. I mean, it's the pinnacle of what we do. But it's okay if you don't actually strive for VEX Worlds, if you strive just to have a program in your school. But if you want to see how these programs impact students from across the world, try to attend VEX Worlds at least once. I guarantee it will blow your mind.
Why do we try new things? Why do we keep pushing ourselves? Because we know that trying something new, or different, or unexpected can be the first step in progress. It's not always easy to adapt and evolve, but it's necessary. It's who we are. Resilient. At Phillips 66, we know that now, more than ever, is the time to try new things. Big things. Difficult things. Things that seem impossible. Because even as we all work to meet the world's energy needs today, we know that tomorrow will bring new questions that demand very different answers. That's why we're always trying new things. That's why we're busy imagining, questioning, creating, and solving. Doing everything we can to find new, more sustainable ways to keep the world moving forward. We don't have all the right answers yet, but we have the right people, our people. Some of the things we try might not work, but a lot of them will. And that's why we'll never stop trying.
RADC is the Robotic Education and Competition Foundation's aerial drones competition, where students build, program, and fly drones. My name is Dan Mance. I am the CEO of the Robotics Education and Competition Foundation. Our thought process behind RADC is to give a lower entry point for students that maybe weren't interested in mobile robotics, but wanted to do something that was technology-based. RADC is for those kids that really like playing maybe video games, having fun with electronics.
It started out 5th grade. We started doing robotics, and we worked our way up to middle school, and we started doing drones last year.
We do small activities together as a team, and that was one of the programs that we tried, was drone flying.
It's helped us learn a lot for like future jobs and such.
It's really hard to get a person up into inspect some of these really tall towers like a chimney stack or even one of these wind turbines. It's something that might be really, really dangerous for a person. You can fly a drone up and do a really great inspection of it. So there are so many different applications with this.
I think our RADC students like seeing things from the air, they like being able to maneuver, they like trying to weave through obstacles without crashing.
What's your favorite part about RADC?
Definitely flying. I like the coding better. We both code and we both fly.
He codes more.
I code. He's funny and doesn't get stressed, so he's able to fly better, and we both become better leaders and better at communicating.
Well, they're learning a variety of skills from leader development, team building, how to be resilient, communication, in addition to the technical skills of programming and coding, ensuring that they're able to get their drone off the ground and communicating between their alliances.
And so we want them to learn how to fly safe, and then when they get into the industry, now they can say, yes, I've done that, I know that's possible, I know that even exists, and so they get interested in that and will now pursue that kind of career.
Thanks to RADC, we have met coding, and I think coding is a big part of our life, because for the RADC, there's the autonomous mode in which is all coding. And we have learned how to code, me and Miguel. And I think I want to implement that in my future career choices as a software developer or web design.
It's still a competition, so they still learn to communicate with their teammates, to problem solve, and that skill transcends any industry. No matter what they do, collaborative, teamwork, problem-solving skills are going to help. I think this is a great way to teach those important STEM and soft skills to our students.
Competition number 1.
It's really fun trying something new this year, especially with drones, since we're more used to driving on the ground instead of in the air. So it's a lot of fun this year trying that.
So at the Robotics Education and Competition Foundation, we like to always look at new programs that we can bring to pique interest of students that maybe weren't interested in more of our larger mobile robotic programs. So the mission of the REC Foundation is always to inspire and engage as many students as we can in hands-on, STEM-related, and really robotics education. So this Bell VRC event does exactly that.
So as students are taking part in this Bell Helicopter Challenge, they're learning all sorts of stuff about engineering and assembly of the drones. And what the competition does is it encourages them to continue.
So our Robodog's been building drones for 9 years. We've built them and flown them before, but we were looking for a competition that would challenge the kids. We do FIRST Robotics, we do VEX Robotics, we do Square One underwater rovers. We play in 7 or 8 different competitions, and we look for things that'll challenge our kids. We really like this drone competition. It's our first year with the Bell Vertical Aviation Program, and I'll tell you, this drone has capabilities that nothing else we've ever done have. It challenges the kid to actually build a drone from the ground up. We really see great problem-solving skills being developed with this particular competition.
It was so fun. It was also our first experience doing robotics.
So I think what's really been unique about this competition compared to any others is the fact that we've got kind of a multimodal aspect to it. So we have ground vehicles, we have aerial vehicles, we have communication between the two, and really trying to put a real world scenario around that is what I think is unique about it and really requires a lot of thought on the students' behalf.
I actually got my start in engineering myself in high school. I was on the robotics team myself, so to be able to kind of see behind the curtain a little bit on how one of these competitions is, how it's made, how it's built, and all that goes into the setup beforehand is just very rewarding. And so it's great to give back to that community that gave me my inspiration for engineering in the first place. I would say it's a great way to provide outreach to these students. There's so many kids out there that want to get involved in these kind of programs.
So I didn't know any.
Welcome to the 2022 Bell Advanced Vertical Robotics Competition. This year's game is the Emergency Firefighting Challenge, where it's you versus the fire. Bell Valley is burning. A forest fire has started on both sides of the field, and it's up to the Bell Valley Fire Department to clear as many burn sites as possible. The playing field is divided into 2 communities, each with 7 burn sites connected to each other via fire spread paths. Each 7-student drive team, operating the Bell AVR drone and its support crew, will have just 5 minutes to fight this quickly spreading fire before Bell Valley goes up in flames. In Phase 1, the fire has already begun to spread into one of the communities. The fire's intensity, or fire score, is represented by windows lighting up on each burn site. Each phase will also begin with a hotspot on one of the buildings heating up, signaling that a fire will start soon. The AVR drone will need to use thermal sensors to detect and clear this hotspot in time, or else its building will erupt into a maximum fire score. There are 3 ways that the AVR drone can put out fires: by shooting a water cannon at active building targets, using a gimbal-mounted laser pointer, by dropping water directly through active rooftops, using 25mm balls, or by clearing away burning trees, using downwash from the drone's rotors. While the AVR drone is occupied in the burning community, the support crew will be headed towards the dormant side of the valley for some fire prevention tasks that will help fight the fire when Phase 2 is reached. Sphero Minis, acting as firefighters, can be delivered to the dormant side's forest, where they will be able to clear trees and fight the fire directly. The Tello drone's mission is to fly autonomous recon paths, discover which fire spread paths can be blocked, and land on top of a high-rise building to communicate this back to the team. The rover vehicle can use this information to clear away burning debris, dig a trench, and block the fire spread path. And finally, the water tower can dispense water into the reservoir to help refill the AVR drone. Phase 2 begins once the initial burn has been fully extinguished by the AVR drone. This time, the second community's fire score can be reduced or blocked before the AVR drone even arrives, thanks to the actions of the support crew during phase.
I'm Becky Stacy. I'm a technology teacher at McKeel Academy of Technology, and so we decided to build C-Perch ROVs, remote operated vehicles. They came as a kit, and it was basically some uncut PVC pipe with electronic components just in plastic bags, circuit board, motors, and things, and the students had to completely put them together, including soldering the components onto the circuit board, waterproofing the motors, mounting the thrusters, and all of that. So it was a great project for the spring, and then we culminated by coming to the pool to test them.
We added weights because the buoyancy of the noodles made it go up too far, so we had to add weights to counteract the noodles so that it could stay buoyant and go down. It took us about a week or so to get all of it together because there was a lot of intricate parts such as drilling holes in the right spots and attaching the motors with wax and water sealing everything.
This program was actually started by the Office of Naval Research. It's called C-Perch, and the idea was to get students familiarized with an underwater drone assembly. So this one is actually a national competition, and here at McKeel we're just starting out for the first year experimenting with it. It was a great opportunity for the students to experience a different aspect of robotics. Anytime you can get the students with hands-on learning, this experiential option of being able to learn what they're doing through action is fantastic. They're able to go through some iterations in the pool where they're testing out, is their robot neutrally buoyant? What are some factors leading to it? And being able to test out whether their assembly of the thrusters and their PVC structure actually worked. So it was great. Anytime you can get the students actively engaged is a good opportunity.
Artemis stands ready. Ready to turn dreams into reality. Ready to return humanity to the moon and take us further than ever before. The culmination of inspiration and innovation, of Herculean efforts and steadfast collaboration, Artemis 1 is ready for departure. And the Artemis generation is about to leave its mark.
What will be a journey of more than 500,000 miles to the moon and back starts right here at Launch Complex 39 Bravo. Although this first flight will not carry a crew, it will test every system in the deep depths of space to prepare the way for future crewed missions.
When the final go is given and the teams at Kennedy Space Center release this rocket, Artemis will roar to life and we will witness the beginning of a tightly choreographed mission.
All engine run 2, 1, and liftoff.
The first 2.5 minutes lift Artemis off Earth and build momentum. It's another 6 minutes of pressing uphill, accelerating to orbit. This is followed by a push from the second stage to raise Orion higher.
And once all the systems are cleared to continue, the second stage will fire again and push Orion beyond the bounds of Earth. At this point, we're going to the moon. It'll take several days to reach our destination, but as we sprint across the void, many new procedures and systems will be tested and proven.
240,000 miles later, Orion will enter an oval-shaped orbit around the moon, one that will take Orion to about 60 miles above the lunar surface and then out to 40,000 miles beyond the moon. This is a distance farther than any human-rated spacecraft has ever gone before.
As momentous as reaching the moon will be, returning to Earth is just as significant and challenging. Every observation we make, every lesson we learn on this journey prepares the way for humans to safely venture out and return home. And so on its final lap around the moon, Orion will ignite its main engine, push out of lunar orbit, and begin the long trek home.
This is a spacecraft built for the harsh conditions of deep space, as well as the intensity of returning home. Nearing Earth, Orion separates from the main power and propulsion systems of the European Service Module and prepares for the final sequence of events. Entering Earth's atmosphere at 24,500 miles per hour, the heat shield endures the fury of re-entry. The air around Orion reaches temperatures half as hot as the sun, but also slows Orion considerably. Until finally, parachutes can deploy, allowing Orion to gently dip into the Pacific Ocean.
To the moon and safely home again. This is the journey of Artemis 1, and it will set the precedent for all that follows. United with partners around the world, this is the challenge we choose. To meet hand in hand, step by step, lighting the way from the Earth to the moon, to Mars, and beyond. We are ready.
Welcome to the 2022-2023 game VEX IQ competition Slapshot. VIQC Slapshot is played on a 6-foot by 8-foot field. This field contains 5 dispensers, 45 discs, 1 fence, and 4 goal zones. The scoring objects in VIQC Slapshot are orange plastic discs, approximately 2.5 inches in diameter and 0.5 inches tall. Robots begin the match contacting the field perimeter wall that is furthest from the fence. In this area, robots will be interacting with 3 types of dispensers. Each dispenser has a unique mechanism that robots can activate to remove discs. Each disc that is removed from a dispenser is worth 1 point. Discs can be scored by launching them under the fence and into the goal zones. There are 4 goal zones: a 2-point zone, 3-point zone, 4-point zone, and 1-point zone. Robots are not permitted to cross the fence while scoring discs, so they'll need to be accurate and precise if they want to score the most points possible. But that's not all. At the end of the match, robots will get a chance to stretch up over the fence and reach for the contact zones which border the field. If a robot is able to touch down in one of these contact zones, then each disc that is scored in the corresponding goal zone will be worth 1 extra bonus point. There are 4 ways to play in the VEX IQ competition. First, 2 teams will collaborate in 60-second teamwork challenge matches, working together to maximize their score. Both teams will receive the same points. Each of these teams consists of 2 drivers and 1 robot. One driver will operate the robot for the first half of the match, and the other driver will operate it for the second half. Second, each team will have the opportunity to play driving skills challenge matches. In these matches, teams have 60 seconds of driver-controlled time to score as many points as possible. Third, each team will also have the opportunity to play programming skills challenge matches, in which they have 60 seconds of autonomous robot operation to score points. No drivers allowed. The scores from driving and programming skills challenges will be combined to determine a robot skills challenge champion. Plus, there will also be remote options available for teams who want to compete from home. Check out the game manual or talk to your REC Foundation manager for all the details. For official game rules and robot requirements for VEX IQ Challenge Slapshot, please see the VEX IQ Challenge game manual found at roboticseducation.org and vexiq.com. To register a team, find events near you, or ask a question on the official Q&A, please visit robotevents.com. Good luck and have a great season.
Welcome to the 2022-2023 VEX Robotics competition season, and this year's game, VRC Spin Up. VRC Spin Up is a head-to-head game that is played by 2 alliances, one red and one blue, made up of 2 teams each. The primary game objects in VRC Spin Up are yellow foam discs. Discs are 140 millimeters in diameter and 20 millimeters thick. There are 60 discs total in a spin-up match, 38 that start on the field, 2 preloads per robot, and 7 match loads per alliance. Discs can be scored in the 2 high goals, 1 per alliance, at opposite corners of the field. Each disc scored in a high goal is worth 5 points. However, robots that are aiming for the high goal had better be accurate, because underneath each high goal is a 1-point low goal for the opposing alliance. In addition to launching discs, robots can also spin the 4 rollers mounted to the field perimeter. Rollers are 250 millimeters long and 60 millimeters in diameter. If the area inside of a roller's pointers only shows one color, then that roller is considered owned by that alliance. Each owned roller is worth 10 points. Each match begins with a 15-second autonomous period, where robots operate without input from their drivers. In addition to competing for the autonomous bonus, each alliance also has the opportunity to earn an additional autonomous win point by owning both rollers on their side of the field and scoring at least 2 discs in their high goal. The 1-minute 45-second driver control period begins once the autonomous bonus winner has been determined. During the driver control period, robots can pick up discs from the ground or receive match load discs through the loader. As the clock winds down, it's time for the end game. At the end of the match, alliances will receive a 3-point bonus for each tile their robots are covering. So, during the last 10 seconds of the match, there are no horizontal expansion limits. VRC Spin-Up can also be played in Robot Skills Challenges, where one team competes against the clock, the collegiate level Vex U competition, where teams design 2 robots using advanced materials, and the Vex AI competition, a completely autonomous competition using industry-level machine learning technologies. Plus, there are remote options available for teams who want to compete from home. Check out the game manual or talk to your REC Foundation manager for all the details. Official rules and game information for VRC Spin-Up can be found at roboticseducation.org or vexrobotics.com. To register a team, find events near you, or ask a question on the official Q&A, please visit robotevents.com. Best of luck and have a great season.
You never been up this high before? You gotta feel like an astronaut. Space dreams.